This is project 4, video number 3, the one in which we add the documentation and finishing touches. I'm going to first state what the function does. Function lens calculator. I think I'll go ahead and type this up while you're I'll pause this while I type it up so you don't have to go through the whole creative writing process with me. You should do it on your own. Okay, I think I got the description of it. Make sure you write it up in your own words, but for the case of lens having used supplied focal length f and an object at a user supplied distance O, from the plane of the lens calculator calculates and displays to the screen the image distance I, the magnification M of the optical system. It also displays to the screen other properties of the system, namely the kind of lens, diverging or converging, the given focal length and object distance, and the nature, real or virtual, and orientation, erect or inverted, of the image. Written by Jeffrey Schnick. Okay, let's put input variables. And we got F. And M. Nope, it was O. Oh, I should mention that we're this whole process we use lens calculator uses the thin lens approximation. So thin lens approximation is the one for which this formula I is equal to 1 over f minus 1 over O. Well, actually the one that reads 1 over f is equal to 1 over I plus 1 over the quantity 1 over I plus 1 over O. That's what that equation is valid for, the thin lens approximation. So I should include that. Thin lens approximation. Output variables. None. Lens calculator prints its output to the screen. In text form. I think I'll leave it. Percent. Okay, so we got that. Then we need attribution. No outside sources. So it's like I remembered num to string and was able to figure out how it worked, or get it to work by trial and error. make sure your attribution does not read the same as mine, unless you did it all on your own. Feel like making a couple extra spaces there. Check for code. Well, a physicist knows what's going on there, but I think it's pretty obvious from the way I described it as well. I don't think we have to describe what's going on there. The image distance is being calculated, the magnification is being calculated. Yeah, this is self-documenting in my opinion. So I think I got it. Let me save it, make sure it's still working. So it's lens calculator. $10 meters, 5 meters, those are pretty big values. Converging, it sure is. 10 meters, 5, that's good. 1/10. Actually, what's that formula? What are the focal length? So it's 1/10 minus 1/5. Be minus 1/10, so I'm guessing minus 10. So it looks like I set up a virtual image situation. Minus 10 meters virtual. Okay. And 2. I said minus 10 for the image distance. Object was closer than that, so 2. That looks 2 times as big. Alright, still seems to be working. Let's go through the checklist. Algebraic solution for the pencil and paper part. Okay, yep, there was not much of a solution, just write down the formulas. Well, there was a little bit of a solution there. Outline of the steps, there's only one function. I got the outline of the steps. Didn't number them in case I had to stick extra stuff in. Didn't want to have to go back and renumber, but I think bullet points there. Reasonable attempt, I think I did that. Writing the code. Point for a program that works properly. Point for documentation and final touches. So to get this point, you must have your name in every file. By Jeffrey Schneck, there it is right there. Code must be documented. Comment stating what the function does. There's that. If it takes arguments, what each argument is. Got that. Takes 2 arguments, F and O. And I state what I call them input variables. I say what it does, what they do, what each one does. For the case of a function that returns 1 or more variables, okay, it doesn't. But I got the output variables covered anyway. For the case of a function that includes segments or statements, I checked through and I think this code is self-documenting. Attribution. Say what video you watched. Provide attribution in your own words. I do have attribution, so I got it covered for me. And that does it. I think I want to, since I haven't saved it, so apparently I didn't change anything, but just to make sure, let's make that a 20. And it turns into a real inverted image with when I make the object distance greater than the focal length. So I think I've got it. Let's call that a wrap for project 4, video number 3.